Hello everyone, welcome back to Exam Ignite. In today's video, I am starting with the Module 2, Part 1 video of the Microcontroller BEC405A Subject 4, VTU 4th Semester 2022 scheme. Here I'll be covering the 8051 instruction set and the addressing modes, are much known for the scoring well in your exam topic. So if you are following the series, then do complete the Module 1. If you have already completed it, do watch the further modules. And this is an exam oriented and a simplified version notes where you can understand neatly. Watch till the end. Definitely you are going to understand the topics. So let's start the topic. In this, I have referred the model question papers and previous year question papers and marked you the important topics and the areas where you have to focus to score well in the exam. So in the module 2, the most expected question and very sure question is the addressing modes, which was asked in every paper. They'll ask you to explain them. I'll say you what to write. Next comes external data moves, code memory, read-only data moves, push-pop opcodes. There will say what a stack, you should know all those things. Data exchanges, then logical operations. Here we are having byte level and bit level. Rotate and swap operation. Till here, I'll be explaining in this part 1 video. In the part 2 video, we'll go with the arithmetic operations, that is flags, increment, decrement, addition, increment, decrement, subtraction, multiplication and division, decimal arithmetic, then jump and call instruction where we have program range, jumps of conditional and unconditional, calls and subroutines, interrupts and returns, then assembler directives. Then main thing, you have to read the programs in related to this module, because program is for sure you'll get the program in any of the section in the question paper in this module. So in the previous year papers, the programs asked were you need to multiply 16-bit with 8-bit number. Then you have to pack the BCD number to two ASCII numbers. You have to add a 16-bit R1 and R0 registers with R3 and R2 and store it in the R6, R5 and R4. Then binary to BCD conversion, that is hexar to decimal from the 50H and 51H registers. Then swap R3 and R4 using the bank 0 using different methods. Then find the largest of the n numbers in the given series. Then addition of A and B, that is two registers, and that should be stored in the 50H. Multiplication of A and B, and that should be stored in the 30H. So at least go do learn these programs. You may expect the similar one in the exam. Next, coming to the another part is they'll ask you to explain the instructions like what is DJNZ. You learn it in the next part. That is a part 2. DJNZ, JNC, DAA, MOX, push, XRL, that is exchange, then DI division, then move are not repeated. They might also ask you to identify whether the given instruction is valid or not. So you should know the concept to write whether it is valid or not. So I'll be saying you how you have to consider which is valid instructions and what is the proper way of writing the instruction. So that helps you in identifying their validity and whether it is a correct instruction or a wrong instruction. So it is important in this module, you need to understand the core topic of what it is to answer these type of questions. So let's get started. Addressing modes, we are having different addressing modes. The different ways of accessing the data is called as an addressing modes. Next, majorly we are having 4, but also another one, fifth one is also I'll explain. The first one is immediate addressing mode, second one is register addressing mode, third one is direct, and fourth one is indirect, and fifth one is indexed. So immediate means source operand is constant, that is it is indicated by an hash in the immediate addressing mode. Here immediate data load into any of the register including the DPTR you can store. For example, move A comma hash 50H means here A is my destination and 50H is my source. So 50H will get stored in the A. So after execution, what happens here is A gets the value of 50H. Similarly, you can also store it in the registers. That is, move R0 hash B 0BH. That is, 0BH gets stored in the R0. Similarly, for the DPTR also you can store For example, hash 1234H. So 12 gets stored in the DPH and 34 gets stored in the DPL. This was about the immediate addressing mode. Next is register addressing mode. Here the register to hold the data, that is we are having the register from R0 to R7. Here data movement between the two registers. Okay. Example, let us consider move A comma R0. Here the content that is present in the R0 will get stored in the register A. Now what gets stored in that can be moved to R3. That is move R3 comma E. Already R0 value is stored in A, that gets shifted to R3. Now add A comma R5 means the value of A and the R5 gets added. So like this, these are some of the instructions. You have to note mainly the thing is you cannot move between the two register by mentioning it as move R1 comma R0. This is an invalid instruction. You have to move it to an accumulator A or any of the other register, and then you have to move back to R1. You cannot directly do it between the two registers. Next is the direct addressing mode. The entire 128 bytes of RAM can be accessed using the direct addressing mode. For example, 002 1FH, here is the location assigned for the bank and stack. So 20 to 2FH, it is a bit addressable space that stores a single bit address. 30 to 7FH, it is the location for the store byte-sized data, and it is the most oftenly used. So in the direct addressing mode, the data is in the RAM memory location where the address is known. So this address is given as a part of the instruction. For example, if I move A comma 50H, then it will load the byte that is present in the memory location, that is what is present in the 50H specified with the instruction 50H, that will get stored in the accumulator. Then from that accumulator, I can move it to 56H like this. Then it gets stored in the 56H. This is how from that memory location we take that data and store it in the register. Now we can use register bank memory location in an instruction. Move R0 comma A is same as move 00H comma A, and move R1 comma R2 is same as move 01 comma 02, but actually it is invalid. Next, indirect addressing mode, or you can say register indirect addressing mode. Here, register is used to hold the address of the data. Here, R0 and R1 of each register bank can be used to hold the memory location address of the data or content in the RAM. That is, R0 and R1 used to point the data indirectly. So here, for the indirect addressing mode, we use a symbol at to indicate the address. See, move A comma at R0 means here the data present in the memory location 30H, which is pointed by the register R0, moved into the register A. Already 30H is mapped to R0. So now that R0's memory location, what is present in that gets stored in the A. So indirectly they are saying A gets 30H memory location. Note, looping is not possible in the direct addressing mode. You cannot loop, but in this indirect addressing mode, we can do increment the pointer registers and do the looping. So move A comma R0, here it moves the content from R0 to A. Add the contents with the contented point by the R1. So that gets moved to A, and move contents present in the DPTR, that is external memory, to the accumulator. So here we will use MOVX for the external memory moving. We use this MOVX. Next comes the indexed addressing mode. Here it is used to accessing the data element if lookup table entries located in the program ROM space, or you can say if it is present in the program code space. Example, let us consider move C at A comma DPTR. This is an instruction where it will copy the contents of the memory location pointed by the sum of the accumulator and the DPTR into the accumulator. That is, it will first add the accumulator and the DPTR memory location content, and that sum will get copied and that will get stored in the accumulator. So you can observe here, program code memory, it will first add, and from there it will store the data. So another one example, you can consider move C A comma at A plus PC. That is what in this the indexed addressing mode, only the program memory location can be accessed. Here A and PC will get added first, and that will point to the accumulator, and that gets stored there. So next comes instruction set of the 8051. Here data transfer instruction, arithmetic instruction, logical instruction, and program branching, that is jump and call instruction. In this video I'll be discussing only the first two. So the first one is data transfer instruction, where we use a group of instruction called move, push, pop, and XCH. So move, here it is having a common, you can say it is a common format of writing the move, that is move destination comma source. That is, first you have to write the destination and then you have to write the source. It will copy the data from one location to another, that is from source location to the destination. For example, if it is move a comma rn, then the content present in the register will get stored in the register bank A. So for example, move comma direct, for this type here, move a comma 30h, that is the instruction that gets copied to the contents present in the memory location 30h to the A. Then comes move a comma at R0. This is an indirect one. Here the contents present in the memory location pointed by the R1 to A. Next is move a comma hash data. Here data is 30h. So immediately it will move the data of 30h is moved to A. So similarly you can write some other instructions. This is what about move. Move direct comma direct. That is using two memory locations. So it copies the contents present in the memory location of 40h to the 20h memory location. Then another one is move direct comma indirect. That is 30h comma at R0. Here it copies the memory location that is pointed by the R1 to the memory location 30h. And next here move direct comma hash data. Here again 30h will get directly moved to the 30h memory location. Next, similarly you can write some other examples. Then DPTR. Here move DPTR comma hash data. Here 1 2 3 4h, it is directly moved into the DPTR, which is a 16-bit register. Data transfer in the external memory. So till now we learned about the internal memory. Now we will learn about the external memory. External memory, as I said before, we are going to use MOVX a comma at R0. MOVX a comma at R0 means copies the data in the 8-bit address that is pointed by the R0 to A. MOVX a comma at DPTR means it copies the external memory data, that is from the DPTR's data is copied to A. So similarly you can write some other instruction at DPTR comma A can also be written. So here for the external memory location access for the data transfer, A should always be included. You cannot directly move to the register. Next is data transfer instruction to access the external ROM. So ROM means here we can use move C, that is A comma at A plus DPTR. It copies the content, that is data that is present in the external ROM, which has an address of what that address. It is obtained by adding the sum of the contents present in the A and the content present in the DPTR. We will add that and we will get the address. That address, what data is there, that gets stored in the accumulator register. Similarly, move C A comma at A plus PC. Here the contents present in the external ROM whose address is obtained by adding the contents of A and contents of PC. Here the PC is incremented by 1 2 point next before adding the content of A for looping. Next, data transfer with the stack using the push and pop instruction. Next one, push direct, that is push on to the stack. Here the instruction increments the stack pointer by 1 and puts the content of B into the RAM location address pointed by SP. So for example, consider here we are performing a push B operation. Here SC will become SP plus 1. It is pointing here 7. So as I make it as SP plus 1, B is having what? 33. That 33 will move from the 7 to 8H here. So the contents of B is pushed into the 8H memory location. Similarly, the same thing happens in the pop, but in a reverse manner. That is what here the instruction copies the content of the RAM location address pointed by the SP to the accumulator by decrementing it by 1. For example, here it was present in the 33 was present in the 8H. So stack pointer will -1 or it comes back to 7. Next is data exchange instruction. Here the data is exchanged between the source and the destination. So for this we are using a word that is XCH, exchange, A comma Rn. The contents of the A register with the contents of the R0 register will get exchanged in the register mode. Next, A comma direct. That is what XCH A comma 30H. That is the content that is present in the A will get exchanged with what? With the memory location 30H. Next is XCH A comma at Rn. That is indirect one. Here the exchanges the content of A with the contents that is specified by the memory location pointed by the R0. Next, XCH A comma at Rn. Here what? Here there is a special one D, that is lower nibble. We use this. So this exchanges the lower nibble, that is 3 to 0 of the accumulator register with the contents that is present in the memory location, which is indirectly pointed by the Rn register. Some of the point you have to remember is all exchange instruction involve A, that is accumulator register has to be involved in this data exchange. Immediate addressing mode cannot be used to exchange this type of data exchange instruction. Next part is the arithmetic instruction, where addition, subtraction, increment, decrement, multiplication, division and decimal operation will be discussed here. Increment and decrement, it allows the addition and the subtraction of 1 from the given number. That is, increment A means it increments the content of A by 1. Decrement A means it decrements the content by 1. Increment Rn means the register content will get incremented by 1, and decrement Rn means decrement register content will get decreased by 1. So INC direct and indirect can also be done, that is 30H. That is increments the contents that is present in the memory location of 30H. Similarly, decrement for the indirect mode at Rn, that is at R1. That is increments the content in the memory location which is indirectly pointed by the register R1. Similarly for decrement. So increment DPTR means here increments or decrements the DPTR value. Our next one is the addition instruction and subtraction instruction. So addition, you have to write add A comma source byte. That is what it will add or subtract the byte content of A and the source byte. Subtraction, same SUBB we will use here. A comma source byte, which is value and result gets stored back to A after the addition or subtraction. So carry, CY and AC are set. That is what carry, and here auxiliary carry, which will be set in case of there is a carry here in the addition. So let us see, add A comma R0. Here the contents that is present in the R0 and the contents of the A get added, and what the result will get stored back to A itself. So here CY and AF will get affected if there is something. SUBB means subtraction. A comma R0 here subtracts with a borrow of the contents of register R0 from the A, and result will get stored back in A. Here the flags that are affected, parity flag that are affected here is CY and AC. For the borrow flag, you can say carry flag or borrow flag. Add A comma direct. Now comes the first direct part. So here add A comma 30H means it will add the contents that is present in the A with the contents that is present in the 30H, and it will store back the result in A. ADDC means you have to include the carry also. Add the contents of A with the carry along with the contents that is present in 30H. SUBB means A comma 30H. Here it subtracts the borrow of the content that is present in the 30H memory location from the A, and then the result will get stored back to A. In the indirect mode, add A comma at R1. Here it adds the content of A with the content that is present in the memory location R1. Again ADDC means with carry. Then again subtraction SUBB at R1 is again it will get subtracted with carry. Then for the immediate, add A comma 30H means for the content of 30 A, 30 will get added. So finally our result will be A plus 30. Now ADDC A comma hash 30H. Here A will result what? A plus 30 plus the carry obtained. Then SUBB 30 means again here subtracts with the borrow of 30H from A, and result back is stored in A. Next comes the multiplication instruction. Here MUL, multiplication AB. That is, in this, the instruction will multiply what? Unsigned 8-bit integer A cross B. After the multiplication, if the result is 16-bit, then the lower bit result will be stored in the A and the higher bit result will be stored in the B. So flag here is C, or you will get a overflow. For example, let us consider move A as 5, and that is what A will have 5 and B will have 7. We have to multiply. That is what the question here. So A cross B is usually what? 5 sevens is what? 35. So in the 35, when you write 35 it in the 16-bit, you will get it as 23H. That 23H can be written as 0023H. So 00 is my higher byte and 23 is my lower bit. So 23 will get stored in my A and 00 will get stored in my B. Similarly, consider for 50 and 0A, 0H. So here multiply, you can multiply it in the calc, you can convert it and multiply it, and directly you will get it as A will get stored as 00H and B will get stored as 32H. Then comes division instruction. Here division of AB. Same, it divides the unsigned bit 8-bit integer in the A and by the unsigned bit in the B. After the execution, A will get the quotient and B will get the remainder. Division AB. Here A by B should not be equal to 0. If it is equal to 0, it will become undefined. Same thing if we will divide, and that gets stored in the A and B. Decimal arithmetic, that is what DAA, that is decimal adjust arithmetic. Addition on packed BCD number and result is also BCD number. By correcting when AF is 1, while adding lower nibble when result is greater than 9 is get added to correct to correct it. It will get added to correct it. Similarly, for the higher nibble, when CY, that is carry is 1, the result is greater than 9, we have to add 6 to correct it. So next, in the next part 2 video, I'll continue with the logical instruction. I hope that everything, the concept that I have explained in this video is very clear for you. So this will end the module 2 part 1 video. Everything is covered. So the concepts are explained in the point of view of the exam so that you revise them very well. If you do find it helpful, please give a like and don't forget to subscribe to Exam Ignite for the part 2 and further videos. If you get doubts or any feedback, please do drop in the comment section. Thank you for watching, and let's keep learning. Let's